coming. So I had the privilege to work on 2 sites of mobile robotics and automation. I was actually for 7 years based close to here in Friedberg in ABB Robotics. I was the CTO in robotics systems. We built manufacturing lines. And now I work in California for Amazon Web Services, more on the digital side, on the data side. So my pleasure to share my experiences how to build future factories, both from automation side and from the data and digital side. So now what is actually smart manufacturing? Even if you think of Industry 4.0 or 5.0, what is the evolution that is happening? There are 2 main technology components. One is the robotics automation, the automation, that next generation automation is happening, and the digital side, which is the cyber physical system. So if you think of what's happening in the cyber system, think of big data, all the .com side from beginning of the 2000s, all the big data computation to what is now happening with machine learning and generative artificial intelligence. Everything around pure cyber computation systems. Now on the other side, you have the robotics, where you think of all the sensors on the field, where you can ingest the data, robotics with sensors, intelligent robotics with computer vision, and force and tactile sensing, and autonomous decision-making, autonomous mobile robotics, and as well as going up to the lighthouse factory, this kind of vision. Now, in reality, there's always components that go mix and match. Now, these are technologies based on how they have evolved and how little bit complexity in terms of their technology development. But if you see the reality, it could be combination in any possible way. You'll always have a digital component and data-driven component. Sometimes only when you think of only robotics component, you will be computing on the prem. In case of the computation side, would be only data-driven, for example, if you want to do some patterns, decision-making patterns. But in combination is where the digital factory happens, right? So I'll give you some examples before I going on to the story behind Amazon, and then come back to what specifically to mobile robotics and intralogistics. Now, if you take one example of IoT plus machine learning and IoT plus cloud compute, okay? Now, there are a couple of examples. Say here, for example, customer here is Lerdo, which is they provide kits for emergency training, medical kits for emergency training. They had problems with wrong parts being kitted or missing parts being kitted and the kit being with wrong number of bill of materials. What we did here together with Tulip is to use a computer vision, looking at how the parts are kitted, in real time guiding the people who are kitting to say whether they are kitting the right parts, also at the end taking the final inspection. It's a classic example here. There's no automation involved, but purely from looking at the digital side of things, how to do improve. There is a very recent development here. Just while on flight, my team informed me about this new customer. Jungheinrich uses AWS to connect their crane systems that do the stocking with predictive maintenance. So they do a real-time data ingestion of the data of these cranes, how they operate in the field, the fleet of cranes from different customers. They look at the breakdown patterns, and then they predict from preventive maintenance to predictive maintenance services. Another example of looking at the product and getting the data and computing in the cloud, getting the results out. Now, these are technologies. What really is the business need behind it? So that is the critical aspect. I mean, technology is always good. Nobody wants to go and put mobile robot just because they're so cool in technology. There has to be a business need and business purpose. So let me tell you the story behind Amazon. By the way, Amazon is my customer too. At AWS, we do quite a lot of data workloads for Amazon in our cloud computation. So before we jump in the real business case, typically people ask me about trends, what is trends going on in the robotics and field. Yes, there are trends. Gartner says about 75% of factories, enterprise factories, are going to be automating their intralogistics in next 3 years. Now, if you look at World Robotics, which actually collects the data from all the robotic vendors like KUKA, ABB, Fanuc, including mobile robotics, They report from the number of mobile robots being sold is growing at 35% year over year between 2022 and latest figures in 2023. So it is widely growing markets. But what is really important is also to look at the trends that do not change. It's always get carried away the trends, what are going to be changed in the next 10 years. The mental model we have is what is the trends from customer point of view that actually are consistently remain the same. If you look at the factories, if you look at the warehouses, the two trends will always be the basic business need. Continuous focus on cost reduction. The cost that the warehouses or the factories need to be reducing continuously. But there could be several strategies to do that. Similarly, the continuous emphasis on increasing throughput and quality. Right? So the intersection of these two are the two cyber-physical systems I was explaining. The next generation of automation, delivering those productivity, delivering that cost reduction. And the next generation of digital transformation, delivering that cost reduction and increasing throughput and quality. How does it impact? For example, if you look at Amazon, right, we have the philosophy of this flywheel mechanism. Customer is always the focus. What is the customer experience? They continuously look for lower prices and wider selection of products they could buy on Amazon, and the convenience in terms of getting the products on time, easy to return the products. So today you can even leave the products at your door, and the Amazon can come and pick it up, right? So that drives the traffic for Amazon, for the customers to come and buy more and more. That drives the more and more sellers offering their products into the Amazon platform, and so forth. Similarly, the infrastructure. The reason behind Amazon automating the warehouses is to lower the cost, lower those times to deliver. Right? Today, we can put in an automated warehouse center, within 2 hours, we can put an order on the truck. Of course, then the transportation management takes place. But 2 hours for the packet to be on the truck to be delivered. So if you look at those evolution, working backwards, those are the ones that dictated the amount of automation that has been now in place and continuously evolving in Amazon. So 2005 is basically where we started Prime. 2014 is a 2-day delivery. We're doing same-day delivery. Today, we have about 750,000 mobile robots installed in 23 plus countries. So we have about 10,000 electric vehicle fleets that deliver in the last mile. Looking at these evolution, it is an example of robotics with cloud compute and AI ML. So here I'm showing the system of how you do the stowing. The stowing takes place when the goods are received, put onto the carts, and the carts go into the storage place. Typically, manual operation. The operation involves finding a place, adjusting it, putting the item. The item is scanned, the cart is scanned, the exact location where it is scanned. So the automation involves multiple aspects here. Pulling the elastic band, finding the space, putting in and our orientation to do it. So the solution involves a lot of things here. The computer vision, looking at the space where it has to find and where it has to insert. Arm to list the elastic band, and the sensing, for tactile sensing for the robot to adjust, push the product in. Right? So this is another level of automation. There is another pure data-driven automation, which you can also see from your side also. But behind the scenes, what's happening here is a huge data compute on the forecasting. Where the products needs to be stored, what would be the demand on the products, whether the demand is regional or global, whether the demand is seasonal. Now this is a month of Halloween. Halloween costumes will be in demand. What type of costumes will be in demand? So those are the forecasting that we started from traditional standard statistical methods to machine learning with the time series data, using deep learning, including the climate change, or including the long-term change, including the weather patterns that are happening, what goods have been required depending on the profiles for a given location. Now, using generative AI, you can also see, if you go online and try to type it, you can see the summaries. You can query, you can do the natural language query, what products you need. Okay. This is the behind pure on the data computation side. Now, coming to specific to intralogistics, we work with Synaos, which is actually across the platform here. What I have seen, these fleet management systems are happening because I have seen personally in a retail customer about 26 different types of robots to do intralogistics operation from end to end. I was involved in my previous job with the automotive OEM. We could not do a complete automation for them because they did not want to have different robotic fleet suppliers. This was 4 years ago, because the traffic systems are not talking to each other. So the freedom for customers to choose which type of robots is very important. Now, what we have doing together with Synaos is Synaos runs on AWS to do the coordination across different robot fleets. It's not only just to do the robotic fleet management, it is also to interface with MES or warehouse management systems, WMS. The third aspect is you need the data. You need the data transparency anyway. The data to be ingested, data to be computed, data to be visible across warehouses for your executive level to see what fulfillment they are doing, what the goods will be delivered to customer, at what stage in the progress they are doing. You need the transparency from anywhere. You need the cloud connection anyway. So the data is being ingested into the cloud for multiple purposes, as well as in real time to do the coordination of the fleet. So today, we have the largest VDI 50/50 fleet in Volkswagen. And the beauty here is there are multiple robots doing the transportation from the storage side to the line side, as well as manual forklifts. Manual forklifts are connected with computer vision and with QR code fiducials to know where that particular location of the particular manual forklift is. Why manual logistics are also important? Two strong reasons. Number one is customers do not switch from one overnight to complete 100% automation. They need stepwise investments to make it happen. So they will be changing or introducing automation in phases. You will always have manual operations in between. The second reason is you still need the data. You cannot have incomplete data trying to do the logistics. You need the SKU units. You need where the units should be transported from A to B, for what purpose. So when you're looking at those things, you still need to include manual transportation as well into your intralogistics. Finally, what I want to conclude here is when you look at the end-to-end intralogistics or data enterprise, what I see from customers is a need from the bottom to the top, and the top to bottom. From the bottom to the top is mostly about what is happening on the factory floor. Whether it is inspection, whether it is what is the breakdowns that are happening, what could be the maintenance that they need to do. That is a line of business, the quality issues and things like that, plant manager issues. From the executive level, they want to see for this customer, what are my deliveries? And for example, in healthcare, each batch is very important. If you have some quality defect in a batch, you have to throw the complete batch away. So it is very important for them to see what's happening for that particular customer deliveries. What's happening on the demand for particular pharmaceutical in the forecasting for those different markets. Those are the things they want to see from the top. So when you are looking at these things, they are dependent on many things. They are dependent on your IT systems. They're dependent on your factory that is producing the data. So the concept we are seeing more and more is a collocation of these data sets to the ability to compute, and ability to give the visibility across their plans, across their systems. So looking at this from the bottom to top is from where you collect the data, you then store the data, and you do computation of the data, and you do produce actionable results. In a complete enterprise, we see workloads for the product design, product engineering. We have smart manufacturing, some of the use cases I've told you already. We also have the supply chain management, not only the demand forecasting, but also the transportation management systems using the cloud connectivity, and more importantly, sustainability. Sustainability within the four walls of a factory, also the scope 3 sustainability when you think of logistics beyond. So again, when you're thinking of third-party logistics, when you're thinking of these different sources of data, it is important to collect the data into one place and do the necessary computation to find what actions you need to take. So our go-to-market approach here is we provide the transformation from the bottom, from the services from the AWS side. We have compute services, we have storage services, a lot of different services you can build using our chips as well as with analytical tools or out-of-the-box tools. We have customers today who build, try, do some experiment on their own, but we are also mostly customers who want from our partners, partner solutions that are out-of-the-box solutions. For example, the Cinevas application for Volkswagen is a partner solution that we offer today on AWS. So you can buy off the shelf as a SaaS solution. The next level is integration. Who are the people, boots on the ground, who are actually implementing it? Some of the partners can do themselves. They also have localized integrators who can actually integrate. They also work with global system integrators. We have partners like Accenture, Deloitte, Capgemini, who are actually good in trying to work and scale across. And scaling is really, really important for large customers. If they do succeed intralogistics at one location, they want to then replicate that at different locations too. So the same copy and paste. So for them, the scaling is important, also means that when they choose different typical vendor, they want to see the global reach. They want to see the global standards spread across their own corporate standards, as well as, like for example, VDI 50/50 standards to be employed and to replicate. We also have consulting partners. We work with former Amazon executives who have their own companies who can actually guide customers how to do the complete journey, end-to-end journey of their automating the warehouses. So who actually can do from scratch, from the greenfield location, how to structure, where should be the plant floor, how to organize it, where do you want to keep the mobile robots and do complete. So at the end, again, these are the different approaches to go to customers and solve. Finally, I want to leave some time to the questions too. The key takeaway I want to see again is when you're thinking of your solutions or your products, try to address customers' key aspects of cost and throughput, and look at how your products can combine both the physical systems, which is automation systems, as well as the cyber data-driven systems. With that, thank you. Happy to take some questions.
Thank you very much for your presentation. I have one question so far from Eduard Wagner in the role as a CIO at TUP. He asks, what do you think AMR manufacturers should focus on, possibly work together more closely?
Definitely, I'd be happy if you want to think about your interoperability between different transportation systems, traffic management systems. One robot talking to another robot, happy to collaborate, what it means to be for you and for your customers, what it means. There are also other technologies like generative AI. I'm seeing more about generative AI guided robotics. See, at the core of generative AI is again advanced decision-making system. When you think of decision-making systems where you need advanced computation, there are ways to do it. I'm going to be here for until 2 o'clock in Cinevas booth. I'm happy to see if you want to see me and discuss any collaboration.
Okay. There's one more question coming in. What is happening with IoT RoboRunner?
The RoboRunner service for the fleet management, we have solutions, better solutions already with our cloud connectivity. We have solutions from SiteWise. We have nice DCV computation service. So we have other solutions which can actually do it. So from going forward, RoboRunner is being sunset, is being for the new customers who won't be available. And again, we have already talked to the existing users of RoboRunner, which is basically the fleet management. Now we work with partners. We have offer what could be the other alternate solutions. Happy to talk to me how to solve these problems, and would be happy to guide you how to do that.
Previously, you talked about out-of-the-box solutions. Could you share with us who comes up with the ideas, or how do you get into this new out-of-the-box thinking mode?
So there are three ways for the out-of-the-box solutions. Number one, always customer. Customers come to us asking they have a solution, they need a problem to be solved. It's a typical pain point. For example, I told you I was working with automotive company. They could only do one section of their intralogistics. They are relying on one single mobile robot supplier. Now there is an actual gap, of course, how to solve the problem. And then we talk to the customer. The second is partners come to us looking at AWS because of our industrial experience, automating factories, because the cloud footprint we have. So they do come to us and say how we can help them to launch their solutions and package the solutions. And the third aspect is technology development. We do work, like some of the examples I showed you are from Amazon Science, which Amazon Science is a separate own division that does the innovation, that looking at what's upcoming and new. The generative AI is, for example, a new innovation too. So we look at technology and we look at what could be solved with new technology. Then again, even if it is a new technology, we go back to the customers. We want to test whether customers really need the technology. And if the technology is something they need it, we see the closest partners who can actually package it into the go-to-market package. And because it's also important for customers to be supported for the life cycle and also for the service and support, on-call service and support. So these are the three avenues we do the development and create those go-to-market packages.
Mm-hmm. When do you see robot foundation models becoming production ready?
Second.
This one.
Robot foundation models, I want to know exactly what. I mean, today foundation models are pretty much driven by natural language and image and media. The question, any specific, what do you mean by foundation models specific to robotics?
Falk Moritz Schäfer, einmal die Frage vertiefen. Ja, wir kommen gleich mit dem Mikrofon vorbei. Die Technik bitte einmal ein Mikrofon. Dann können wir alle an der Frage teilhaben. So, geht sofort los.
Hi, thanks. Yeah, looking at the acquisition or takeover for covariant, right? We're working on robotics manipulation and foundation models in this area. Where do you see it? When will it happen?
So covariant is acquisition by Amazon Robotics. It's purely for internal purposes. I have no comment on that one. But when it comes to foundation models, so far I have seen only vector-based computation, which is basically dividing information into vectors and computing to do the statistical modeling. For example, the way text is generated, the way image is generated. Particularly on robotics, I will be interested if there is any other views in the technology. But from it comes to the foundation models being used for robotics, yes. I mean, if, like for example, robot breakdown manuals, 500 pages of manual, who wants to go through those manuals, right? So you can interact with the robot and try to see if an error code comes, explain to me what this error code. And then robot can explain what that means. So I've seen those applications. So definitely yes. But specific to robotics, if there are other ways to do, I'm very interested to know as well.
Okay. Considering the time, I would say anything you come up with later, you can of course approach. You will be here tomorrow as well, or today?
No, only today until 2 o'clock.
Okay, only today. So take your chance, and this is your applause. Thank you very much.
Thank you.